Hello, this is Mr. Collier, and today we're going to be multiplying terms with indices, also known as exponents. So let's take a look at an example. Let's say we had the product x squared times x to the power of 3. Now what happens here? What is this going to simplify to? Well, with multiplying and with most rules of indices, you can write out what the exponents mean, which is repeated multiplication, and then figure out what the rule is. So if we have x squared, that means, let me change to a different color, we have x squared, that's going to be x times x. And if we have x cubed, that's simply x times x times x. Okay, and this whole statement here, we have 5x's. You can rewrite this without brackets, x times x times x times x times x. And altogether, how many x's do we have? We have 5x's. So we can write this expression as x to the power of 5. So notice, if you look at the exponents in our original expression, we have x to the power of 2 and x to the power of 3. And how does that relate to 5? Well, that's 2 plus 3 equals 5. Because there's a product of 2x's here and a product of 3x's. Altogether, you have a product of 5x's. Okay, so let's check see if that works with some actual numbers. Let's say we had 2 to the power of 2 times 2 to the power of 3. And our rule here looks like we have to add the exponents. So that equals 2 to the power of 5 according to our rule, which is, that's 2 times 2 times 2 times 2. Let's write it out. And that is actually 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so if we wrote out the actual numbers now, let's try it another way. Let's write out the 2 squared, which is 4, and the 2 to the power of 3, which is 8. And what does 4 times 8 give you? It gives you 32. So they match, so it looks like our rule works for at least 2 to the power of 3 times 2 to the power of 2 times 2 to the power of 3. So our rule looks like it's going to be to multiply, you add the exponents. And we can write this rule algebraically as well. Any number, a, to the power of m times now the same base to the power of n. It's going to give you a to the power of m plus n. So that's how you write it algebraically. You add the exponents. Okay, let's do a couple of examples here. So the first example, we have a to the power of 4, which is 4 a's multiplied by each other, and then a to the power of 3, which is 3 a's multiplied by each other. Altogether, you have 7 a's multiplied by each other, so you have a to the power of 7. Just add the exponents together. You get 8 to the power of 7. In this example here, now look at this example. Can we do x to the power of 10 or something like that? Can we add the exponents here? Well, no, you can't. So the simplest form is x to the power of 7, y to the power of 3, because these bases are not the same. So you cannot simplify here by adding the exponents. Okay, they have to be the exact same base. Like over here we had a and a. They have to be exactly the same base, or you cannot add the exponents. Okay, in the next example, well, we have x's and y's, and we can just take them one at a time. So we have 2 x's here, so that's x times x, and I have another x over here, so that's 3 x's altogether, so it's x cubed. Just add the exponents, right? You can write a little 1 here if you want, and then 2 plus 1 is 3. Then you have y to the power of 6 times y to the power of 4 gives you y to the power of 10. You add the exponents. Okay, the next example, you have to use the distributive property to simplify. So you can do ab squared times this term and ab squared times that term. And you can write it out like this. ab squared times a squared b c squared minus ab squared times bc to the power of 5, like that. Okay, so in the first term here we have a times a squared, less like a to the power of 1. So we have a cubed, b squared times b. Well, that's like b to the power of 1. So that gives you b to the power of 3. And there's no c over here. There's a c here, so we just write c squared. Okay, minus a times, and there's no a's over here, so it's just a. B squared times b, like we already saw, is b cubed. And there's no c here, but there's a c to the power of 5 here, so we have c to the power of 5. Okay, and these exponents are different, so we can't add them together or anything like that, so this is simplest form.